Hola, hello everybody. Welcome to another webinar of a developer series. Thank you so much for being here. And thank you so much for watching this video if you are watching us in YouTube. Today we are going to talk about testing. I'm going to let the floor to Brendan.
Yeah, thank you so much, Dulce. So today will be, the topic is testing smart contracts with Truffle, but it's kind of a 2-for-1 deal. You're going to do testing with JavaScript and then another hands-on session with testing smart contracts with Truffle as promised. So before we begin, I'd just like to point out to everyone that we have a link at the bottom of the slide. And we'll paste it inside the inside this group now. Dulce, if you want to do that. Yeah, it's basically the same slides as what you see here on my screen. You can follow along, and it'll be helpful because there are links, and you can just click on them. You can't click on the links in the video inside this webinar platform.
Sure.
Okay, cool. So next up. Just like to point out that today's session, we're going to talk a little bit, but it's mostly a hands-on session. So it's you can choose to watch and observe, right? That's one option, but you can also like try out and get your hands dirty by actually doing the things that we'll be doing during this webinar. And I think that's the way, or we think that that's the way that you'll get the most out of today's session. So for those of you who are joining us in this webinar for the first time, I'd like to let you know that there's a huge series of webinars, and that's over 50. In fact, Dulce just told me this morning, today is number 60. So yeah, please go ahead and check that out for all our past events. There'll be plenty of webinars on development. Dulce, I noticed that you've put in the URL here for the prerequisites. There is another one. I'll just actually put this one. So,
awesome. Yeah. Thank you.
That one I think is just internal. This is the published version.
Oh yeah, sorry.
Okay, cool. Anyway, I'll let Dulce introduce herself now.
Yeah, before I start to introduce ourselves, I want to talk about IUV Labs. Brendan and I, we both work in IUV Labs, the umbrella organization for RSK, Taringa, and Reef. RSK is a smart contract platform secured by the Bitcoin mining hashing power. Therefore, is the most secure one. Taringa is a social media platform, and Reef allows peer-to-peer interaction and decentralized communication, decentralized storage, and decentralized marketplace. We in IUV Labs are building a fully decentralized internet for financial inclusion. About me, I am developer advocate for RSK and Reef. I am Mexican. I am an economist and I'm a data scientist, and I worked in banking and a fintech startup. I love food and fresh veggies. Actually, I've been doing gardening during the quarantine. You can find me on Twitter with my handle. Please, Brendan, introduce yourself.
Thanks, Dulce. So it sounds like we've got picked up some similar hobbies during the quarantine. I've been farming butterflies or caterpillars most of the time, actually. Because they just decided to lay a lot of eggs on my lemon tree, or more like tree sapling, and then that just became a thing by chance. And then I've also been doing some composting, which is pretty hard to do in an urban setting, but figured out a way. Yeah, so okay, so I'm also a developer advocate for RSK and Riff. I am from Singapore, and I am currently studying Spanish. So I'll embarrass myself with a couple of lines. Ya he estado aprendiendo por más de 200 días en Duolingo. Estoy practicando mi español ahora mismo. But that's all the Spanish that you're going to get from me today. All right. Okay, so here are the prerequisites for today's workshop. So for those of you who signed up via the platform, you would have noticed that you got an email about an hour before today's webinar stating like here's the links to the slides, and also here are the setup, right? So you need to set up a few things before we proceed with the hands-on parts of the session. So for those of you who have just joined and haven't looked at this before, I'd highly encourage you to check these out. So this link will take you to a page that looks like this, and for this particular hands-on, you'll, well, there are two of them. So for both of them, you'll need a POSIX compliant shell, Node.js, and then for the second one, you're going to need, you're going to need Java and RSKJ. And of course, you'll need a code editor to do any editing. So please go ahead and install all of those things that you need in the background, if you can do so while we just go through the slides. And hopefully by the time we get to the hands-on, you'd have completed them. If you want a step-by-step walkthrough on how these are, the actual installation process for all of these, please go check out our previous webinars. Quite a few of them go through them in detail. Okay, so first up, we're going to be doing JavaScript testing. So I know the title of this is Testing Smart Contracts with Truffle, but you'll see soon enough why we've chosen this approach, because I think it's worthwhile understanding testing without the complication or additional layers of technology that smart contracts bring to the table. So we talk about testing by itself, and then once we've got that down, then we move on to smart contracts, which are a bit more complex to test. So you'll see what I mean coming up to this. So just to make it very clear, our first hands-on has got nothing to do at all with smart contracts. It's just going to be pure JavaScript. And then our second hands-on, we're going to actually go on to test smart contracts. All right. Let's see. So now we've got some objectives. The first thing is, what is testing, right? And it's basically the idea of you've got an application, and you need to verify that it works. And there are many, many techniques used to do that. And then subsequently, what we're going to do is think about some software engineering principles related to testing, and also the hands-on culminate in a hands-on session where we use Mocha to do our testing, to perform our testing. So, Dulce, would you like to talk about
Mocha? Of course. Yeah. Actually, I want to say that I really like this approach because it allowed us as a developer to have a framework about Web3, but also about Web2. Like you can really navigate between two words very easy. About Mocha, that is like JavaScript Web2 word. Mocha is a test runner or a test framework for JavaScript that can run either in the browser or in Node.js. Today we'll be using Node.js only for this part. The main task of a test runner is to execute tests and to generate a report. But before we get there, we first need to understand some terms such as implementation, specification, and then we can look back to the test runner. Implementation. Let's start with implementation. Implementations form the actual part of the code that perform the functionality of your program or application. You can find like IMP, the acronym or the short,
yeah.
IMPL.
The short form.
The short form, yeah. A specification is very similar or are very similar to implementation because they are also code. However, they are not executed by the user of your program of application. Instead, the specification run the implementation in a certain predefining way. Hey, Brendan, could you explain us the test runner, please?
Yeah. Thank you very much. Okay, so a test runner is sometimes also referred to as a test framework. So what Dulce mentioned earlier on about the specifications running the implementations in certain predefined ways. That's spot on. And the test runner is the thing that enables that to happen. So those predefined ways are actually the tests that comprise the specification. So what happens is you've got the test runner, which executes the specification, which in turn executes the implementation. And then in the background, while all of this is happening, right, the test runner also does something else, which is to observe the behavior of the specification and the implementation. And the most important thing it does is to check whether there are any errors, and if there are any assertions, check whether the assertions are true or false, right? And based on that, it collates all of these observations together and it produces a report. Now, the one that we'll be using today, this particular developer tool or test runner, is called Mockup, and we'll see that in action later on. All right. Before we go on to the hands-on, there's just a little bit more theory that I think would be useful to check out after this webinar, because there's a lot more to testing and theory about tests than what we've just covered. So we don't have time to go through all of this for sure. Like this could be, a whole day if we wanted to. So these are just basically links to, the definitions, if you will, on Wikipedia. But I encourage you to explore this further. But for now, we've covered the basics that are required for our hands-on. So let's just go on to that. All right. So I'd like everyone to open up this link over here, developers.rsk.co/that URL. We will paste that. Thanks, Dulce. You've already pasted that inside the chat. And that will open up a page that looks like this, right? So I'm just going to follow the steps, and hopefully you can follow along for those of you who've got the prereqs installed. All right. So you need a POSIX compliant shell, Node.js, and a code editor to make this work. So the first thing we're going to do is to clone an example repository that I've prepared. And we'll take a look at that in a bit. So I'm just going to do that, git clone. All right. And then I'm going to do npm install. All right. Excellent. Okay. So, oh, sorry, I forgot to cd into this folder. My bad. All right, cool. So this should take about 30 seconds tops. It's a little bit faster on my computer because I've installed these particular dependencies before. Now, you can view the contents of this folder like this. Whoops. I want to look at node modules, and you can see it's got a fairly flat folder structure. If you don't have the tree thing, you can use a file explorer like My Computer in Windows, etc., or Nautilus in Linux. I forget what the Mac one is called. I think it's Finder. Yeah, so you can use any of those applications to look at the folder structure as well. Okay, so these are just NPM related stuff. These are documentation. The two things that we care about are the two files, feature1.js and feature1.spec.js. This is the implementation, and this is the specification. The file names don't matter so much. We're just following convention here. So what I'm going to do now is I'm going to open up this folder in my code editor. I'm using Visual Studio Code, but feel free to use whatever you want. And then I'm going to do all right, cool. So I've got feature1.js open up now. And
can you do the font a little bigger, please? Aha.
For the reminder, Dulce. Okay.
Thank you.
Yeah, always. Sorry, just rearranging my windows so that I can maximize the amount of space
you have to tell them that you have a big screen. That is kind of hard to configure.
I think my screen dimensions are 34 inches for this monitor, so I have to amp up the font size whenever I'm, doing a webinar or something. Okay, cool. So we have a very simple implementation here, which consists of a single function named add, and it is supposed to return the sum of its two parameters, right? But you can see here that I've got a little bug in there. And so the objective of this exercise, this hands-on, is to write a test for feature one, and then we observe the error, and then we fix the bug in the implementation. That's going to be the whole flow for today, this particular hands-on. All right, next up, we're going to open up feature1.js, .spec.js, and this is the specification, right? Sorry, my bad. Let's undo that. All right, cool. So right now we have a test file that contains a require for assert. Assert is a Node.js built-in, and what it does is it checks whether certain conditions have been met, and its intended use is to pass or fail test cases. Now, in feature1.js, you saw the add function that's imported through the require statement into this test case. So this is where the bridge between the specification and the implementation occurs, right? The add function is the specification, and this entire file is, the add function is the implementation, and this entire file is the specification. But the specification doesn't do anything at the moment. We just have, a blank test file. Okay, so what we're going to do is we're going to run some tests. npm run test, right? Now, for those of you who are wondering how that's been set up, you can take a look at package.json, and you can take a look at that. So what it's actually running is Mocha, right? So don't that's been all set up for you. You don't need to do that. It's just for your information more than anything else. All right, and you can see from the output as well what commands being run. So you run Mocha and the zero tests because the zero tests. You haven't written any. All right. So now we're going to write our first test and then run the test runner again. So I'm just going to copy this test over here and paste that there. All right, cool. Now I'll save the file, and what we can see here, I'll just break it down. It should be self-explanatory, but just so that we're super clear what we're doing. This is the implementation. We're giving it some specific known values, and whatever it returns, we're storing it in a result. Then this assertion, right? We're going to say, I want to ensure that the result that I got from calling add over here is this specific values, this specific value. So I'm saying if I do add, if I call add on 1 and 2, I should get 3. Makes sense, right? It's just syntax that we have to learn. This syntax is specific to Node.js and Mocha, and there are many ways to do it, but this is the most, simple way to do it. You can have something like Chai or other libraries to do your assertions. That's an option as well. But assert is the bare bones minimum. All right, now let's just go and run test again. So npm run test. And you can see here we get this result, right? So we've done the same thing, Mocha run spec.js. And this time you'll notice something different. We'll see feature 1 add, and it works with specific values. And you'll notice that hierarchy matches exactly what we see here. Feature 1 add, and it works with specific values, right? So our test runner is finally running a test, which is great. Unfortunately, that same test is not passing, saying, hey, we've got a return value of 4, right? But the expected value was 3, so my assertion has failed. And so, as mentioned earlier on, Mocha as a test runner, what it's done is not only has it run the specifications, which in turn run the implementations, it has also been observing the results and collating them together. And what you see here is a report. It's saying, this is what has happened, and the tests are not passing, essentially. So it's up to us as developers to figure out what's gone wrong and go and fix it. So now that we've got a failing test, let's go and figure it out, right? Now, I want to point out something which, I go into a bit more detail here in this particular thing. But basically, what we have here is a true negative, right? So we verify this test is actually correct. We should indeed get 3 when we add 1 and 2. But then we look over here and we see, hey, the implementation is wrong. So the test result was negative, and it's a correct test result for it to be negative. So how do we fix that, right? So we fixed that bug, fairly simple fix. I've even put a comment in there to make it super obvious. And then we save that. Now we're going to run the test one more time. npm run test once more, and you can see here, this time we've got the same hierarchy, right? Feature 1, add and works with specific values. And this time we've got a tick mark, no error message, and we've got 1 passing, right? And so now what this means is that we have a true positive, meaning the test result is positive because the test have passed and it is true. Now, we can go further, right? So congratulations on making it to the end of this workshop. And I just like to say that this has been a very simple, like bare bones minimum, if you will, of how to do testing in JavaScript using Mocha. But there are a lot more things to explore. So we have the concept of true negatives and true positives, which we just saw today, just earlier on. But we also have false negatives and false positives, right? This is where scenarios in which your tests are incorrect. Now, if you want to explore that concept in greater detail, I'd encourage you to check out this link at the bottom, where we explore that and other concepts in more detail. All right. So hopefully everyone was able to follow along, and we're going to go back into our slides now. Cool. So let's see. All right. So yeah. So just before we wrap up, I just wanted to point out the thing I mentioned about true and false, positives and negatives. So there is an exercise where we go in through all 4 quadrants of this thing in the link that I just pasted inside of the Livestorm chat. So yeah, please go check that out. What we did, just to be clear, what we did today, we started off in this quadrant with a true negative, meaning the tests were correct, but the implementation was wrong. And then we ended up in the true positive column where both the test and the implementation were correct. All right. So next up, we have testing Solidity. And this is what we promised earlier on. So that JavaScript testing thing was just sort of like I guess a sneak peek at the bigger picture of testing smart contracts. So we're gonna switch gears here, and testing smart contracts is a bit more involved than testing just JavaScript. What we're gonna do is we're gonna switch our test runner from Mocha to Truffle. Right, and Truffle has a subcommand called Truffle test, and that is essentially going to be our test runner. Now, the gut feel that I have, right, about anyone who's attending is why did we do Mocha at all, right? And how does that have to do with Truffle test? And it turns out that Truffle test, right, the reason why we did that, Truffle test is like 99% Mocha. In fact, it actually is just a wrapper around Mocha, and they've added a few extra things to Mocha to make it work in the context of testing smart contracts. Otherwise, it's pretty similar, right? You write the specifications in JavaScript as well, right? You do have the option of writing a specification in Solidity, but we're not going to do that today. And then your implementation, instead of JavaScript files you're testing, you're actually testing Solidity files, right? So this is the difference, right? And to go into this into a bit more detail, right? What are the main differences that you need to care about between Mocha and Truffle tests, right? So earlier on, you may have seen require statements that allow you the specification to import the implementation. In Truffle test, your implementation is not JavaScript, right? It is actually a smart contract. So we need to use a Truffle built-in called artifacts that require in order to import the specification. And that does all the background tasks required for JavaScript to be to interact with a smart contract using Web3.js. So then the next thing we have in Mocha, we saw describe blocks. I'll just go to the specification over here. So you can see these describe blocks. So what we used them for was to group tests together. Now here we only have one test, so it was a bit redundant. We didn't really need the describe blocks. But let's say you have a project with lots of features, and each feature has lots of tests, right? And in that case, the use for describe blocks will become apparent. Now, in Truffle tests, you can use describe blocks, but in most cases, you will substitute describe blocks with contract blocks, which function in pretty much the same way, except that they group tests for a particular instance of a smart contract together. And we'll go into what that means later on. And finally, inside the describe block, you'll notice that the callback functions, right, have no parameters. You'll see that this parameter list is empty. Whereas in the contract block for Truffle test, you'll actually have something inside here, the equivalent of accounts, right? So you'll actually have a specification, you'll actually have a parameter, which in your callback function called account, and that's actually the list of accounts. And that's one of the things that you get from using contract block that a describe block doesn't give you. Okay. All right. Then we also have a bit of theory as well before we go on. And for those of you who are following along at home and haven't got the prerequisites ready, I strongly encourage you to spend this time to get RSKJ installed while we go through this theory. Okay, so this is a bit of a computer science stuff, but we'll just sort of gloss over most of the theory and just talk about the parts that are specific to smart contracts, because understanding state machines and how smart contracts relate to them or model state machines is very important when it comes to thinking about how to test them. Right, specifically, smart contracts are stateful systems, right? So whatever is stored, data is stored in the smart contract, the variables in it is the state, right? And at any point of time, it can have one state. And what do I mean by at any one point of time? It's when you're at a block. So the state of the smart contract at block 1 is this, at block 2 is this, at block 3 is that, so on and so forth. And state transitions are essentially when a function is called inside a smart contract, and that function modifies the data that is stored against that smart contract, right? So what exactly causes that to happen, right? So you have to have a transaction in which that function is called, obviously. So that means that a user has to call that function by signing a transaction, and that transaction needs to get added to a block, and that block needs to get added to the blockchain. And that's when the state transition happens. So that's when you have let's say your smart contract's in block 5000, and then transaction is added, and in block 5001, there is a new state for that contract. So in between 5000 and 5001, there was a state transition on this particular smart contract. That's how it happens. So with that in mind, right, we are going to do a hands-on in which we're going to try to test 3 different things: state transitions, and events. Now, there's one other thing that I would have liked to cover, but in light of time, we're not going to. But I'll provide reference material at the end of this for those of you who are interested to go deeper. So, and that's about mocking. So the prerequisites for this particular workshop are a POSIX compliant shell, Node.js, Truffle, as we had previously. Sorry, Node.js, and we also need Truffle and RSKJ. So all of the instructions for how to do them, how to install them, are on this page over here, which you should have in the links. I'll just paste that again for those of you who haven't seen it yet. And the one that we will be doing now is this. And I see Dulce has already done that over here. So thank you for that. Okay, cool. So let's begin. So the first thing we're going to do is we are going to start with a repo, right, that we have already set up beforehand for you. And that will give you a interesting. Sorry, I started in the wrong folder. we'll do a git clone of that and cd into that folder. All right. Now we've got our Git repository, and now we're going to do the same tree output. Right. Okay, cool. Let's see. We've got, okay, so I think I haven't updated this tutorial, but we can see the live version here. Okay. So what we have here is cars.sol, migrations.sol, so on and so forth. So these are your smart contracts, and that has been done completely for you. And these are the migrations. These are the scripts that are used to deploy them. These ones, we're not going to go into any of that. We're not concerned with that. This is your Truffle. This is where the specifications for the implementations are stored, right? So these are the implementations. And this is a pre-configured file telling Truffle how to connect to RSK networks, among other things. So the two files that we care about the most are this cars.sol, that's our implementation, and that's complete. And this cars.spec.js, which is our specification, and that is incomplete. So today what we're going to be doing is going to complete the specification in order to test cars. We're going to test initial state, and state transitions and events. Those are three things that we're going to do today. All right. So let's open up this file. Code. I'm just going to use Visual Studio Code for this, and we have got cars.sol open. So I'm just going to do some window management here. Close this window, and over here we've got this. All right. Cool. Okay, so we've got a car smart contract, and just a brief tour of this. What state does it have, right? The smart contract, it has an integer that stores a number of cars, and it starts off at 0. And it also has a mapping that stores a set of car objects, and these are the fields that each car object has. It also defines an event, right, for a honk, and we'll get to that later. So today, what we'll be mostly concerned about, as I said before, is testing the initial state of the smart contract, which is here. We'll be testing a state transition on the add car function over here, right? Which essentially creates a new car. Which essentially creates a new car and adds it to the mapping, right? And then at the bottom, we have a honk car function, right? Which allows us to emit the car honk function, car honk event, right? And we'll be testing that as well. All right. Now let's move on. We've got an incomplete specification that I'd like you all to take a look at right now, which is in tests/cars.spec.js. And here we go. All right, so we've got compare this to our previous smart contract, our JavaScript testing thing, where we had add that was required from feature1.js, right? So here we don't have a require statement, right? We have artifacts that require, which is a Truffle built in. And through that, we have a JavaScript object that wraps around the smart contract, and that's done via Web3.js. And you don't need to care about how that works because Truffle does it all for you. Okay, and then subsequently, we have a bunch of contract blocks, right? And within each contract block, we have a callback function, right? And I'd just like to point out the differences. Instead of describe, as we saw earlier on in our JavaScript testing, we have the contract blocks. And instead of having an empty parameter list, we have a parameter list that contains accounts, and this is an array of account, the public keys for the account. And these will be useful for writing a test, because anytime you want to do a transaction, right, you need to sign that transaction using an account, right? So that's where you get them from. You get them from here. Worth noting that within a contract block, you use a single contract instance, and that is torn down is essentially discarded. And then when you go to your next contract block, you have a brand new instance of the contract block. So that's the other thing that a contract block does that a describe block does not. Yeah. And finally, we have this contract block, which is the same as the other two, right? It's the same structure and everything, except that you see something here called before. Now, this is the concept of a before is not something that Truffle has added. This is actually something that comes straight out of Mocha, right? But what it's used for is to set up the initial state to something other than the default in order to test it, right? And you don't need to care about what's inside, right? So that's all been done for you. Just we're going to focus on writing the test. So for those of you who are looking there and figuring out what it's doing, don't worry too much about it. Okay, cool. So as before, what we're going to do is we're going to run tests, right? So I'm going to do npm run test, and you'll notice that this is going to fail, right? I'm going to get an error. And the reason for that is because our smart contracts need to connect to a blockchain, and we don't have one running, right? So for those of you who are following along at home and you have done RSKJ, you will not have got this error, right? Because you'd have got to this step where you started your RSK node, right? So I'm just going to copy that command, right? And you'll notice that I have RSKJ core 201 papyrus all jar, same as what I have here. And you should have already had that set up from the previous steps. So what I'm going to do is I'm going to paste that here, and I'm going to start it, right? And observe that I have no output. This is expected. If there are any errors, you'll see something. So the fact that I don't see anything, that's great. Now, there are two flags to be aware of. This enables cause. So let's say you're creating a decentralized application, where you have something in a browser, for example, that's interacting with your smart contract stored in this. You need to disable cause in order for that to happen. We're not using that today, just letting you know what it is. And the other thing is that we've started reg test. Now, reg test is actually a local host only blockchain, right? Meaning it doesn't really connect to a peer network. And yeah, let's leave it at that. Okay, so we have RSKJ running now in reg test mode, and now we're able to run the test again. This time, Truffle will be able to connect to the reg test network. I think I forgot to do npm install. Sorry, I got ahead of myself. I forgot the npm install step. All right, I'm going to stop the blockchain again, just so that we can see the error from before. All right, this npm install step does take a bit longer than the previous one, in which I believe we only had Mocha installed because Mocha is pure JavaScript. This one involves installing a bunch of Web3.js stuff, which unfortunately involves the C compiler. So if you see, this type of output, or this kind of output, that's quite typical for something that includes C, and it tends to take a bit longer. So yeah, don't worry if it takes like a couple of minutes or so to do that. Okay, so I have ended the process for RSKJ. It's not running anymore. I'm going to run npm install. Sorry, I don't need to do that. Npm run test. And this time you'll see the error saying that I'm not able to connect to a blockchain. See, there was a timeout while attempting to connect to the network. All right, now let's start RSKJ once more. Okay, so now a block header. Aha. Okay, so this, yeah, this is actually a known error. All right. Cool. So I've removed the block data, right? So this happens when you upgrade from a previous version of RSKJ to a new one. On reg test, you just have to blow away the previous blocks. Okay. This time we're able to start the blockchain without any error, and you can see that from no output. Okay, finally getting there. Okay, now if you run npm run test, I'm expecting it to actually run. All right, excellent. So using network reg test, that means that I have successfully connected my Truffle to RSKJ. So now it's going to compile some smart contracts and submit the necessary transactions to interact with this this node here, and we see that we've got 0 tests passing. Now, if you compare this to the output from the pure JavaScript mocker test, you'll notice that it's pretty much identical, except for this part over here, right? It's just a little bit of extra stuff for the smart contracts. Cool. All right, so that means our test runner is running and our blockchain is running. Okay, so a bit of a runaround, but we finally got there. Okay, so now what we're going to do is we're actually going to write some tests. You notice that we have 0 tests passing, and we want to actually have some. So the first thing we're going to do is the initial test. All right, so we're going to do that case here. All right, so we've got initialized with 0 cards. So what are we actually doing here, right? So when a smart contract is deployed, right, one of the things that is important to check is its initial state. So we're expecting the value of num cars to be 0 upon deployment. So when a contract is deployed, right, and there are no transactions on it since the deployment, what is the state, right? And one of the things that we can test is num cars, and its value should be 0. That's essentially what we're doing. We're obtaining an instance of the smart contract called cars, and we're doing .numcars.call. .call means that we're making a call onto a function without actually submitting a transaction to a blockchain, right? So we're just essentially querying its value, right? And then we're storing it in initial numcars, and we're doing pretty much exactly the same thing as what we did before in the JS testing. We're doing assert.equal, and we're saying numcars is equal to 0. Now, you may have noticed that 0 in this case is not a number, and we're doing a .toString. And the reason for that is because the smart contract doesn't return a JavaScript number, but instead it returns something called a BN, which represents a big number. And this is because you can go up to very, very huge numbers in smart contracts, much bigger than the numbers that JavaScript can represent intrinsically using its number type. But you don't need to care about that. Just remember to use .toString and quote your numbers, essentially. So that's been done. Let's run the test. All right. So I'm expecting this to take a bit longer because essentially we've got a test to actually run. Not too bad. 44 milliseconds. If I were to do the same command with time, you'll see a lot more because that includes the setup and teardown time from Truffle test. Yeah, so you can see 44 milliseconds, and we'll see the output later on. See what overhead a smart contract actually gives us. Yeah, so it actually takes 13 seconds. So that's a bit misleading, isn't it? Okay, cool. Next up, I'd just like to point out that our test for initial state is the simplest possible test that we can write on a smart contract. Once we involve state transitions, it does get a bit more complex than that. All right, so now we're going to do precisely that, which is to add a new test for state transition, and we are going to be testing the add car function. You'll notice that the test code is actually a lot more verbose. Like this is what effectively 3 lines of code, and this is way more than that. Okay, so this test will take a bit longer, so I'm just gonna save that and run it in the background, right? You don't need to prefix your npm run test with time. I'm just doing that for demonstration purposes. You can just run npm run test. So while that's running, I'll explain what's going on. So we're getting an instance of the car smart contract, same as before. And this time what we're doing is, I'm going to skip ahead to this one. We're going to call the add car function with a bunch of parameters that it expects. And we're using account1 to do so. And we're also paying the smart contract a certain amount of value, right? So what we're expecting this to do essentially is for num cars to increase, right? So you see num cars increases by 1, and we're also expecting this mapping to contain a new value. So mapping with a value of 1, when we query it, we should get back the new car that we just inserted with those parameter values. Yeah, and of course, in addition to the parameters that we specified, we've also got a status, a default status, as well as the car's owner, which is the message sender. And that's been stored in the mapping. So that's what the implementation says it does. And now we've just written the specification to verify that it does do that, right? So that's precisely what we're doing. Instance.addCar that, and then we're using account one, so that should be the owner, and the status should be parked. So we can see here these values in the assertions over here, right, correspond to what we've set in the parameters, and these values over here, the default value for parked, and this one is that the owner is accounts one, which is the account that sent the transaction and the account that, therefore, the account that paid for that particular car object. Okay, cool. So that's I would say that essentially does the test, the assertions that test this particular implementation. But earlier on, I did something that maybe was a little bit tricky, and I skipped. Now we're going back to that. You notice that I'm actually doing instance.addCar once over here, and that actually does a state transition. But over here, preceding that, I'm doing addCar again, but this time I'm doing .call. And for those of you who are familiar, you'll notice that .call, right, is only used to query values. It never sends an actual transaction to the blockchain, right? And why are we doing that? First of all, why are we calling addCar twice or invoking addCar twice? And why does one of them have a .call and one of them doesn't, right? And the reason for that is because we are doing an assertion on the return value, right? So we'll see here, returns car ID, and car ID is modified here. So whatever the new car ID is, in this case, the initial state was 0, and after our state transition, we're going to increment it by 1. So we expect the value to be 1, right? So if you attempt to get the return value from here, right, the actual state transition, you'll find that it's not possible, right? Because you get a transaction and the transaction doesn't contain the return value. So what we need to do is we need to emulate or preview this call in order to actually get the value for that particular thing. So in order for that to happen, we need to send it the exact same values inside, right? And this is exactly what we've done here, the exact same parameters as well as options. Cool. And that will actually give you the return value, which in this case is car ID. And we're evaluating that car ID is 1. That's what's happened. So this bit here is a little bit more complex. And if you have any questions at all about this or anything else in this webinar for that matter, I would strongly encourage you to check us out. Leave that to URL. That's not what I intended.
Already, Gitter? Yeah, I did.
Yeah. Sorry. I used .com for some reason. Copy the address. Cool. So we've got RSK smart / getting started. So if you're inside of this room, you should be able to ask any questions. All you need is a Twitter account or a GitHub account, and you're good to go, right? You just press that button and you should be able to start chatting with us. As you can see, there are quite a few RSK people answering questions quite actively here. So yeah, if you have any questions, need further explanation, please don't hesitate to ask there. All right. Yeah, and a slightly more detailed explanation of all of that's here in this tutorial. Okay, so I've already done npm run test earlier on, right? Before all that explanation, and you'll see what has happened. So now instead of 1 test, we have 2 tests, and we'll see that hey, we've got a positive result for both the initial state and the state transition tests, and that took 15 seconds to do. So a couple of seconds more than before. All right, now moving on. Let's test events, right? So as mentioned earlier on, this this events test, it has a before block, and you don't need to do anything inside there, but let's just take a look at it to see very quickly what it does, right? It gets an instance of the car, it adds a car. This is a purple sedan, right? It's got 4 doors. And this one is a yellow, I guess, convertible because it's got 2 doors. And more importantly, account 1 owns car 1 and account 2 owns car 2, right? And none of the other accounts own anything, right? So, and then at the end, we just do a sanity check to check that we do indeed have 2 cars inside of the system. All right, cool. So that's what the before block does. And the reason why we need to do that is because our tests for events do require that cars already exist in the system. That's just quickly take a look at the implementation of honk car, which is the function that emits events, to see what we're really testing. So we need to pass in a car ID. So this is the car that you own, right, as checked for here, as well as another car's ID, right? And that other car needs to exist, right? If it doesn't exist, we're not allowed to honk at it, right? And if all of that, if all of those checks pass, then you get to do a honk. And what a honk does is it essentially emits an event. All right, let's do cars.spec.js, right? We're going to write the specification to test that implementation. So what I'm going to do here is copy that test and replace this. All right, so we're going to perform the state transition, which emits the event, right? So let's do that. So I'm going to run the test and let it run in the background. And while we're waiting, I'll explain what's happening as before. So we're getting an instance of the car smart contract, and we're just calling the function. All right. So I'm using car 1 as the car that I own, and car 2 as the car that I own, and car 1 is the other car, the car that is getting honked at, right? And I'm doing so from account 2, and that's perfectly fine because account 2 does indeed own car 2, and so therefore this function should succeed. And we also know that car 1 does exceed in the system, so therefore this function should also succeed. Both checks should pass, right? And now the rest of this code, what it does is it essentially says, okay, I got the transaction back, the transaction data after this transaction was completed, and I'm going to extract the logs property and assert that I have exactly 1 log. And a log effectively is basically is the event that was emitted. All right. Then the next thing I'm doing is I'm saying, okay, so I've got that first event, right? And I check that the type of the event is car honk, and the parameters of that event, the from car is 2 and the at car is 1, right? That's what this test does. And let's do that. Now we'll see this time we've got 3 tests, right? So we've got initial state transitions, and the new one is the new events test. We've got a honk car and another car, and that has passed. So we've done, congratulations, we've done the test for all 3 types of things to do with a smart contract when you think about them through the lens of a state machine. But I would like to do just one more test, right? And the reason for this is that so far what we've tested is the happy path, right? And by happy path I mean tests that are, I guess essentially performing assertions on what should happen when the user behaves correctly, right? Meaning the user is using the smart contract or interacting with the smart contract in the manner that they are supposed to. But that's not the case all the time, right? And our test would be incomplete if we didn't also check that these tests verify that when the user does or interacts with the smart contract in a way that they're not supposed to, right? How should it work, right? So that's the reason why we have these require statements, right? So it's kind of defensive, right? So what if someone tries to honk someone else's car, a car that they don't own? The smart contract is going to reject that because we have this check only car owner, right? Which does something similar to this, right? And then we have another check here, which is specific to this honk car thing, which says that the other car needs to exist. And it does that by checking whether a certain field that it has, which is the owner field, has indeed been set, right? So it does a bunch of things to check that the user is not calling the honk car function when they shouldn't be, right? So let's write a test to assert that those checks actually do indeed work, all right? And I call this a failure scenario or failure test, right? So the tests are expected to pass when the smart contract rejects this particular transaction, right? So and this is precisely what I'm talking about. So as before, I'm going to write the test and then run it, and while it's running in the background, talk through it so as to save a bit of time. So get an instance of the smart contract, right? And then we do the exact same thing as before, right? We call the honk car, invoke the honk car function, right? And the same parameters. Car2 honks at car1. But this time, right, I'm doing something different, right? I am actually not the owner of car2 because I'm sending the transaction from account number 3. And account 3 doesn't own any cars at all, right? It has no cars, right? The only account that should be allowed to call this function is account number 2, right? So we're going to do that, right? And what we're expecting is that this transaction doesn't actually ever get done. There is no transaction. And the other thing that we're expecting is that this statement will actually throw an error. And that's the reason why we've wrapped it in a try-catch block, right? This try-catch block says, okay, if there was an error, I am going to not crash the entire test. I'm simply going to capture that error and then so as to be able to do some manual assertions after that. So that's precisely what I do. I'm going to check that there was indeed an error, right? That was thrown, and I'm going to check that there was no transaction that resulted from invoking this honk car method, right? And we can see over here, yep, that's what we've got over here. So we've got cars events. This time instead of just one, we've got two tests in that particular contract block. And we can see here we've got 4 tests passing. So we've got a part for the events. We've got a passing happy case or happy path. And then we've also got a test that verifies that the failure scenario, or at least one of the failure scenarios, is working as intended. Okay, excellent. All right, and that brings us to the end of this particular workshop. I mentioned earlier on in the slides that there was one more thing, mocking, that I would like to cover. So you'll notice that I have a couple of lines commented out over here inside the smart contract, right? And this is the actual implementation, original implementation of the smart contract. And I'm just going to run this test in the background so that you know what I'm talking about. You can see here that what it's doing is saying it's using a sort of a hacky way of getting the time of day. Please don't use this in a real smart contract. This is just for demo purposes. And it's saying, oh, okay, if it's between midnight and 6 a.m., I am going to prevent this car from honking. Right? That's what it's saying, right? And you notice here that the tests that were passing previously have failed, and rightly so, right? Because it isn't between midnight and 6 a.m. according to the blockchain state. But you'll notice that if I were to do this same test several hours later, the same test will pass, and that means that these tests are not robust, right? They're not actually doing tests properly, like because the implementation hasn't changed, the specification hasn't changed. Why is it passing at some times of the day and sometimes of the day it's not, right? And so what that means is that I need to change my specification such that it is more robust and is able to handle the time of day scenario. And one of the ways to do this is to actually mock the get time function, right? However, we are not going to go into that for the purposes of this workshop. It's a bit too advanced, and also we don't have enough time for that in the workshop. So I'd strongly encourage you to check out this thing. Right, there is a mocking Solidity for tests. This one was originally done in Ethereum, but the concepts are the same, and I believe the code is the same as well. So you should be able to follow along with that one. If you are interested in going deeper into the concept of mocking. All right, cool. And yeah, let's get back to the slides. So, Dulce.
Yeah, thank you. Yeah, Yeah, thank you so much, everyone. I'm just gonna wrap up, and I want to say, like, while this webinar has been primarily intended to be hands-on, we have covered a lot of theory too, because we know it's important. This theory allowed us to do with software engineering principles around testing and thinking about the smart contracts in terms of states and state transitions. And in the hands-on section, we create a JavaScript application and test it with a JavaScript, and followed that up with creating a smart contract in Solidity and testing with JavaScript. Mm-hmm. Very important. You will have noticed that we use RSK Graetz, and maybe you are wondering, if you are new in blockchain, what is Graetz? Graetz is a testnet. It's a network designed to be private and for testing only. What that means is not a public network and has not peers. There is no peers for you to connect with or to connect to. And this is totally intentional for this kind of test where you are doing actively development and you need faster interaction, and local host only blockchain is the perfect and the right choice. However, not that you always have the option of running tests against your smart contracts deployed on a real peer-to-peer decentralized blockchain network, such as RSK testnet or even RSK mainnet. In the case of RSK mainnet, usually we use that, or we reserve that for the very, very last stage in a project. And you have to consider gas price hikes, and also you have to check like economic incentive based attacks or network congestions. We strongly recommend for testing use RSK Graetz. Thank you so much, everyone. Please check our link of developer RSK .co webinars.
Dulce, one sec.
Sure.
I just thought of something I should probably mention, because you're talking about testnet and mainnet, right? So this Truffle config file, which we haven't taken a look at earlier on, right, actually contains all of the configuration required to connect to Ridge test, which is basically nothing, right? But then you also have configuration to connect to testnet and mainnet, and a couple of other ones in case you're running a testnet node locally or a mainnet node locally. So you have like, I guess, 5 different options of networks to connect to. So if you go to package.json and you look at this truffle test -- network Ridge test, right, you can do the same thing, this truffle command, right, and you just replace Ridge test with any one of these names that you actually want to connect to. So let's say you want to connect to testnet, it'd be something like this, right?
And I want to say, like, for our Ethereum developers who are testing for the very, very first time RSK, you just change the Truffle config file, and you can see the benefits of RSK. Like, it's faster and it's cheaper in terms of it's affordable in terms of gas cost, and it's pretty good. I'm gonna say that.
yeah, we might have bias though. So go try it out for yourselves and do the math and work out which network is faster or cheaper on your own. I'm sure you'll like the result. Okay, Dulce, back to you.
Thank you so much, Brendan, for this amazing webinar. Please check it out, our next webinars. Also, you can check out YouTube channel with this video. Our intention is to provide all the materials because we believe in open source. We believe in shared knowledge. You can use all the material that we create. Everything is in our website, slides, workshop, and also try to connect with us if you have a question in Gitter. You have the link, and I think that's it.
Yeah.
Thank you so much for staying with us.
Yeah. So Francisco has just pointed out that in the chat that we have a YouTube channel and all our webinars are being recorded and they will be posted on that channel. If you want all the hands-on material all in one place for this particular webinar, that link, which I posted at the beginning and just done again at the end, it contains links to the slides, the prereqs or setup, JavaScript testing hands-on, as well as smart contract testing hands-on. So feel free to follow along at home for those of you watching on the.
Okay. We have a question from Oscar Fonseca. Thank you so much, Oscar. These are really good questions. What are the networks for working with RSK and to deploy with mainnet? Okay, RSK per se is a sidechain of Bitcoin. What that means is it's a blockchain per se. It's an open public blockchain, and you use RBTC as a mirror currency. That means like one RBTC is the same as BTC, is what you use for pay your gas. It's basically that if you hold Bitcoin, you can pay gas with Bitcoin, maybe by doing use an exchange between RSK, RBTC and BTC.
Mm-hmm. Yeah, and just to tackle the concept of a token specifically, right? When I get asked this question, I always clarify what exactly a token means. So every blockchain, or I'd say maybe most blockchains, they have a protocol native cryptocurrency. So in Bitcoin, that is Bitcoin, the Bitcoin network. In Ethereum network, the native cryptocurrency or protocol level currency is Ether. And in the RSK network, the native protocol level currency is RBTC, or what we call smart Bitcoin. And as Dulce mentioned, there is a 1:1 exchange between RBTC and Bitcoin, and you can use a two-way peg to accomplish that. And so, yes, you do pay for gas or for any transaction using RBTC in pretty much exactly the same way that you use Ether to pay for gas for transactions on the Ethereum network. Now, the second part of the question is tokens as tokens. So there are many types of token standards, but the most popular one is an ERC20 token standard, which you probably would have heard of in 2018 and 2017 when there were lots of them going around. Now, RSK has a suite of products that help to build the decentralized web called RIF, which we mentioned, which Dulce mentioned right at the beginning of this webinar. You've got a name service, you've got a storage service, you've got a marketplace, you've got several other things that you would need in addition to the blockchain itself, in addition to the smart contract platform itself. Now, there's a RIF token, which is ERC677, but compatible with ERC20 tokens that you can use to pay for services that interact with these RIF products. Yeah, so I hope I've answered your question in both aspects of it. So one aspect is smart contracts or any transaction. Yes, you pay for gas using RBTC, which is the protocol level currency. And then for interacting with RIF services, you will use the RIF token. I hope that answers your question.
Yeah, really good questions, Oscar. In the first webinars, we show how to connect with MetaMask, with Nifty Wallet, the Faucet. If you come from Ethereum world, you will see that RSK has few benefits, for Ethereum developers. And the benefit is you can port your dApps pretty easy, and it's kind of a lot of concepts are the same. Yeah, there is a few things that are different, but it's kind of the same idea because the virtual machine of RSK is based in the Ethereum virtual machine in Java. Then if you're familiar with Ethereum, it's going to be pretty easy to use RSK. Are the same concept.
Yeah, so just to go into a bit more technical detail, if you don't mind, RSK has an implementation called RVM, the RSK virtual machine, and the opcodes in RVM are compatible with the opcodes in EVM. So the smart contracts layer is compatible, right? And then the other thing that you care about as a end user developer, right, is that they have JSON RPC compatibility. So all of the JSON RPC requests that you expect to be able to make, for example, using Geth or any Ethereum-enabled wallet, you can make those same JSON RPC requests to an RSKJ node, right? And because of these two things being compatible, right, you'll find that as an Ethereum developer, right, transitioning into RSK development, there are very, very few things that you actually need to learn from scratch. Like all the existing tools, they just tend to work out of the box with configuration changes. And all of the existing end user infrastructure, for example, like if you develop a D app and your users are already, working with MetaMask, for example, as Francisco has pointed out, then they can also use MetaMask with an RSK application. They just have to add the config for the RSK network, and that's it.
Awesome. Yeah. Thank you so much. We are gonna ending this webinar just saying we have open positions. Please check it out, the website IOV Labs, and click in careers. We have open positions. We hire globally. We are a remote and distributed team. With an amazing and inclusive culture.
Okay, I'm going to ask on Oscar Fonseca's question. So yeah, this RPC configuration is definitely here. It's let me see, JSON RPC. There we go. So every single JSON RPC request is documented here in this link. And you can see exactly whether it's supported or not and descriptions as to why, right? So yeah, so this should give you all of the details. And for example, if you want to do this, you'll just jump right to the documentation. Cool. So yeah, as a developer of a decentralized application or a smart contract, I would say that the differences are minimal. You don't need to care about them 99% of the time. Hope that answers your questions, Oscar. Cool. Okay, I think we can wrap that up for now. Thank you so much, everyone, for attending. Feel free to reach out to us at developers. Sorry, I'm going to type developers@iovlabs.org, right? At that email, if you prefer email, or you can reach out to us on Gitter at this chat room. And of course, we have our developer portal, which has lots of useful information, such as this JSON RPC page. Okay, thank you very much. Bye.
Bye.